In this lesson, we will get to know all the components on the Arduino Uno board that we will use throughout our training and learn the features of the Arduino Uno board. I will explain the Arduino pins to you through the figure. I prepared a presentation to explain the process step by step. Now let's start our tutorial. Our first component will be the power input. Arduino can work with an external power source. This jack is used to enable Arduino to operate with an external power source. Voltages between 7 and 12 volts can be applied to this input. This voltage to be applied can be provided with an adapter or a 9-volt battery. The voltage applied here is automatically reduced to 5 volts, which is the operating voltage of the Arduino. Our second component is the USB connection. The computer's USB connection is used to both program the board and provide power to the Arduino. A 5-volt voltage is applied to the Arduino via USB, which is already equal to the operating voltage of the Arduino. Our third component is the reset button and is used to reset the Arduino device. Thanks to this button, we are saved from the trouble of disconnecting and reconnecting the power of the controller. It should be noted that the reset button will not delete the codes in the Arduino microcontroller. This button only restarts the device. Our fourth component is Arduino's microcontroller. Arduino has Atmel Atmega 328P microcontroller. It is an 8-bit microcontroller with high performance and low power consumption. This microcontroller works with a frequency of 20 MHz, that is, its operating speed is 20 MHz. 23 of the 28 pins on it are programmable. We can use 23 pins as input and output pins. This microcontroller, which is a memory type flash, operates in the supply range of 1.8 volts to 5.5 volts and at temperatures between -40 degrees C and 85 degrees C. This microcontroller is also sold separately. There are 3 memory units in Arduinos. The first of these is flash memory. Arduino programs are stored in this flash memory. Our second memory type is SRAM, that is, static random access memory. It is the type of memory where variables are created when the program runs and their values can be changed when necessary. Our last memory type is the EEPROM memory type. This is to store the programmer's long-term variables. The flash and EEPROM sections are non-volatile. Data stored in these areas is not erased even if power is cut. However, information in the SRAM section gets deleted when power is disconnected. Arduino Uno 3 version has 32 kilobytes of flash memory, 2 kilobytes of static RAM, and 1 kilobyte of EEPROM. Another component is the chip that provides serial communication via USB. An Atmega 16U2 serial communication USB provider is available on Arduino, creating a virtual COM port to the operating system. Atmel Atmega 16U2 uses standard USB COM drivers and does not require an external driver. However, clone Arduino models have CH340 and 41 chips instead of Atmega. This is the main reason why the price of clone Arduino models is lower than the original. If we are using a clone Arduino model, we need to install the driver into the operating system before we connect the device. Another component is ICSP pins. There are 2 in the original model of Arduino. So what is ICSP? ICSP allows the microprocessor to be programmed via these pins. So it is possible to program Arduino with the help of these pins. ICSP pins on the right side are connected to Atmel Atmega 328P microcontroller. The ICSP pins at the top, close to the USB input, are connected to the Atmega 16U2 chip. There is a power LED here which turns on when the Arduino is powered and stays on as long as electricity is available. There is an integrated LED. It is connected to the digital pin 13 of the Arduino. When the 13th pin of Arduino is energized by making it high, this LED also lights up. When the power is cut off by setting it to low, this LED also goes out. Now let's talk about TX and RX LEDs. These LEDs light up during serial communication. As you can see in the figure, pin 0 and pin 1 of the digital data inputs are TX and RX pins. RX means receive, and TX means transmit. During serial communication, these LEDs light up to inform us in what state the serial communication is taking place. Another set of components are analog inputs. Arduino has 6 analog input pins between E0 and E5. When voltages between 0 and 5 volts are applied to one of the analog pins, digital data between 0 and 1023 is determined according to the value of the voltage. The analog to digital converter ADC in the Arduino provides the conversion of the applied voltage into digital data. For example, when a voltage of 5 volts is applied to an analog input, 1023 digital data is produced. Similarly, when a voltage of 1 volt is applied to the analog input, it produces 204. We can use these values in various programs and control devices. Reading data from sensors is done via analog inputs. Thanks to analog inputs, information such as temperature, light, sound, pressure and distance range can be read from the sensors. This reading process is performed by voltage calculation, and as I just mentioned, numerical values are produced according to the incoming voltage value. Now it's time to explain the power pins. Power pins, consisting of 5 pins, perform energy duties. We can provide continuous voltage to our circuits with the help of pins labeled 3.3 and 5 volts. GND pins, which stands for ground, perform grounding operations. VIN enables Arduino to work by applying external voltage. When a voltage of 5 volts is applied to the VIN from outside and at the same time a ground line is provided to the GND pin, the Arduino works without the need for another source. Other connection here is the reset pin, and it performs the same function as the reset button. Since this pin is programmable, Arduino can be reset by coding it when necessary. IRF pin is used to show how many volts are output from Arduino's output pins. The shields attached to the Arduino use this pin to decide whether it will work with 3.3 volts or 5 volts. Another pin is a pin that does not have any naming or labeling and is known as not connected pin. I could not find any information explaining the operation of this pin or showing its usage. Other important pins are digital inputs and outputs. Let's examine these 14 pins, which are ordered from 0 to 13, in detail. Pins 0 and pin 1 are the pins connected to the serial communication port. We use pins 0 and 1 in cases that require serial communication, such as Bluetooth. We also call these TX and RX pins. Some of these pins have a wave sign on them. As you can see in the figure, there are wave signs on pins 3, 5, 6, 9, 10, and 11. These pins can also be called PWM, which means pulse width modulation pins. Thanks to these pins, we get analog results from digital data. For example, we can adjust the brightness of an LED thanks to these pins. As we mentioned before, Arduino has analog inputs from E0 to E5. No specific connection for analog output on Arduino. However, among the 14 digital input and output pins, it is possible to use these wave sign pins as analog outputs. In other words, it is possible to adjust the voltage given to a device with the help of these pins. There is also a GND pin at the top. This is used to provide ground line like other GND pins. There is an RF pin here. This pin determines the voltage measurement reference for the 6 analog inputs of the Arduino. As you may remember, there are 6 analog inputs and they can receive voltages between 0 and 5 volts and produce numerical values in response. We can change this range thanks to the RF pin. The other pins are SDA and SCL pins. Arduino needs some communication protocols to communicate with other Arduinos or sensors. One of these protocols is the I2C protocol, which stands for Inter-Integrated Circuit. This protocol is a type of serial communication. We will include detailed information on this subject in our future tutorials. We have come to the end of this lesson where we provided information at the beginner level. See you in our next tutorial.